Yeah, yep. The big thing is we could not get 64% to happen. I'm going to push record. Ben's not here to remind me. Well, he is, but he's not. I pushed the record button, Ben. Okay, so we couldn't replicate his result. Now, we were questioning his result. So A is like what made us suspicious, or sus if you play Among Us. He did 64% in the gym, but he was claiming 80. So that's what made us question it. But then we further gathered evidence because we couldn't replicate his 64%. So yeah, we concluded Stickney was a liar. So we're going to use the same logic today to kind of go through that process again and continue to formalize it. So looking at another situation, ooh, not this. So somebody didn't change the slide title. Who was that? All right, so we're going to look at gender discrimination today as our scenario, and then do a similar simulation, and then summarize again our findings and make a conclusion. So we're going to keep formalizing the process with the significance test. So these are our two goals today. We're going to set up hypotheses and claims again about some sort of measurement, some sort of claim, a population parameter. And then today we're going to work on a little more clearly interpreting the result we got on our dot plot. So we're going to try to interpret that percentage that we get and then make our conclusion again about our situation. So does anyone need a copy of the notes? We're going to be on this page, 9.1 part 1. Titled Gender Discrimination. If you are in the physical classroom right now, Mr. Crossman, if you're there, I don't think these kids have Tessa doesn't have a copy yet. There is on top of my bookshelf, going on an adventure. On top of my bookshelf, there's like a wire basket that's in there somewhere. There's a big stack of Chapter 9 packets. They're not stapled. But Tessa, I think, needs one of those. Everyone else, I believe, got one. I think Kai got one Monday. I don't quite remember. But if you are at home and you'd like a digital copy again, there they are. So I'm going to drop that link. Okay, you got it, Tessa. Good. I can't remember who got it at this point and who hasn't. Okay, so we're on this page, 9.1, day 1. We're going to do another little simulation today with our situation about gender discrimination. So far, it looks like the Google is cooperating. So I'm going to switch and share this tab. Make this look slightly bigger. Okay, so here's our scenario today. We've got a local engineering firm had to conduct a series of layoffs, which is probably a little more real this year with COVID. But this is last year's activity, actually. So they will lay off 10 people. That's what they've decided. The company has 180 employees that could be laid off. Everyone's equally qualified. So the company decides to use a lottery system to be carried out by the manager to decide who will be laid off. So everyone has the same qualifications. There's no lack of seniority or things. But unfortunately, the 10 layoffs have to happen. So the manager posts a list of employees to be laid off. 5 employees are women and 5 are men. One of the women claims this is gender discrimination and starts a lawsuit against the company. So first thing I want to do with you guys is we're going to just kind of decide on the situation, what information seems to be important here when we kind of set the scene. So I'm going to call on a couple of you because to me you're all virtual today. I'm not in the physical classroom. But let's go ahead and take a peek at what we think is important what in this scenario. So Lillian, what information sticks out to you? Do you mind unmuting yourself? I'm going to highlight. Tell me what to highlight. What seems important?
That the company has 180 employees that are all equally qualified.
Okay, so we do know a total number of employees, and equally qualified, is a good thing to know. Very good. Yep. All right. Let's call somebody else. Saul, are you there this morning? Do you mind unmuting? What else seems to be important in this scenario?
The people laid off are 5 women and 5 men.
Okay, why does that seem important? 5 and 5.
I think that's our sample.
Yeah, that's our result. I mean, that's essentially it's 50-50. Yeah, we got our kind of like our sample. Sure. Yeah, that's our sample, definitely. So 50% men, 50% women, which doesn't sound like gender discrimination. I mean, it's equal, right? Okay, anything else that seems important? Let's call on Kai or the physical classroom. I think you should be able to unmute, not get crazy feedback. What do you got?
That the manager is using a lottery system to pick the people.
Okay, yeah, that's it. That is important. Why might that be important? What are your thoughts?
Because it's it's random rather than like the manager's just picking the people maybe like doesn't like.
Yes. Okay. So good old randomness. So we do have randomness. We do have equal qualification. So nothing's sticking out to us there. And then we do have our sample was 50-50. So thinking back to the Stickney scenario, we're going to investigate the claim of potential gender discrimination at this company. So what we want to do is decide what our true, it's almost like the state part, like we've done this before. We want to describe the population here, and I'm going to pray that I can type. Okay. So we have a proportion of employees that have been laid off, and one woman is claiming that it's gender discrimination. So we're looking at the proportion of women that are laid off at this company. So that is my true proportion of things, like in general, based on this company, what are the actual like proportion of women that are laid off that exist at this company? So that's kind of what we're going to investigate. And specifically, we're going to investigate this 50-50 scenario, this 50%. So it looks like half the women got laid off. So we're going to do another random simulation similar to Stickney, but we're going to do some dice rolling today, actually. Okay, so I'm going to take this out because I don't want to set up another poll and make the Google angry. But okay, let's converse again. So question 1 is asking, the manager responds, how could there be gender discrimination when half of the employees laid off were female and half were male? Okay, so we've got a discrepancy. So what additional information do you think we need? It looks like half and half, but what other information might you want about this company before we start our investigation? What else could we need? Cheyenne, what other information would you want? What do you think? Do you mind unmuting?
If the women and men were probably chosen randomly, or if they were not chosen randomly.
Okay, so what is the lottery system? We're gonna assume it's random, but I mean, that is a good thing to question. Like, how do you work the lottery system at this company? That's very fair. So we may want some additional information on that. Chris, what do you think? Do you mind unmuting yourself? What other information would you want in this scenario?
I would say the proportion of men to women.
Oh, interesting that you would say that, and I actually have that. Okay, so we know there are, delete this box. We know there are 180 employees, but like, what is the breakdown actually between the employees? So here, I have that breakdown. So out of the 180 people, there's 60 females and 120 males. So now knowing this information, and the fact that 50% of the people laid off were women, why is this one woman a little upset, perhaps? Now that we see the breakdown, what are our thoughts? I call on somebody again. Let's see. Go through my list. Who haven't I heard from? Aiden, feel free to drop in the chat. I know you can't unmute. So we'll let you type for a second. Why is this a little sus now? And then. Okay. All right. Let's take another peek. Lillian, why is this? Do you mind unmuting? Why is this a little sus right now? 60 feet. The breakdown is 60 and 120. What are your thoughts? And then we'll see what Aiden said.
Because it's not what's the word? Like, it's not 50-50 like males and females. It's like 66 and 33, but then they fired like it was 50-50.
Yeah, so that's the big issue here is we have a 1/3, 2/3 setup. And yeah, Aiden's kind of saying the same thing here. There's only half as many female employees as there are males. So we have a 1/3 to 2/3 breakdown, but they fired like it was 50-50, which is a problem that we want to investigate. So what we're going to do, we're going to set up our claims. So I'm going to start using statsy symbols here. We're going to set up our claim in a statistical way. So this is for question 2, kind of how you want to start getting used to writing things. So we have our null hypothesis, which is assuming the claimed amount is true. So in this case, we're going to say like, all right, what's the proportion of women, that actually get fired here? Is it possible to get 50% by random chance? Like, was it a fluke that just 5 out of the 10 happened to be women? So what we want to set up here is we know it's a 1/3, 2/3 split. So I'm going to use decimals because those are a little easier for me than fractions, but the fractions are a friend. So for our null hypothesis, what we're going to claim is that the company, it is true that we have a 1/3 of the people at the company are women. But what is the likelihood that we actually fire more women than that? Perhaps it was, just a fluke, and we want to see if we can replicate that result. So here we're going to say, well, hold on. The alternative to our claim is that more women got fired. So my alternative hypothesis is written, the proportion of women that have been fired is greater than the 33%. So this is what I'm investigating. So in the stats world, this is what gets set up every time. These are your hypotheses, and they get written just like this. So you look at your claimed amount. So in our case, this is reality at the company. But our reality for people getting fired, alternatively, hence the A here, alternatively was the 33% was greater than the people that exist at the company. So what questions right now do you have about how I set up these hypotheses, sorry, plural. And then we're going to talk about how we would simulate this or try to replicate what happened at this company. So drop in the chat or feel free to unmute. Shout at me if you want. What questions do we have about the claims I just set up, the 2 hypotheses? I'll wait the appropriate awkward amount of time in case somebody's typing. Okay, I'm going to assume there's no questions. So what we're going to do is, so Saul said, he's like, okay, hold on. So our p hat here, the result we're going to look at was 50-50. So our p hat, I don't know why I'm writing, I could have just typed that. Our p hat is 0.5. And we want to investigate the likelihood of getting half of the people by random chance out of the 10 that just happen to be women. It's possible. It could be a fluke. So this is our investigation. We're going to use dice today because we have a 2/3, 1/3 setup, and so the dice has 6 sides. So I'm going to drop a dice link in the chat here. You're going to want to click on that link, and it should take you to a page like this. The only thing we're going to change is we're going to do this for 10 people. So we're going to need 10 dice to be rolled. So you do want to change the number of dice you're going to roll. So go ahead and take a quick second and click on that. And then we'll describe what numbers are going to mean what, which numbers represent the women and which numbers represent the men. And then we'll go ahead and do our dice rolling. So just make sure you set it to the 10 people or 10 dice. Each dice is a person. Now, the only thing we do have to decide is which numbers, this could be a really big font, which numbers are going to be the women and which numbers would represent the men or a man being chosen. Actually, hold on. This is a woman, man, male, female. Okay, so It's 2/3, 1/3. So we're gonna have to pick two of our numbers on the dice. It doesn't matter which two are gonna represent the women. So Ben, which two numbers do you want to represent the women? Does not matter which two. Do you mind unmuting?
What, two numbers?
Yeah, so dice has 6 numbers, and two of those numbers will have to represent a woman. You know, like a woman got picked because we needed 2/3 of the numbers or 1/3 of the numbers to be women. So which two numbers do you want?
3 and 4.
3 and 4. All right. Doesn't matter which two. So then that means if you roll a 3 or a 4, that means a woman got laid off out of the 10. If you roll 1, 2, 5, and 6, that's going to represent a man that got laid off. So we're gonna simulate. I'm gonna show you how here. I'm gonna do it with my own thing. Share this tab. Look at me tab sharing. Can't remember to share when I'm in the physical classroom, but now I can share all my tabs. Okay. So once you have set to 10 dice, that's our 10 people that are gonna get laid off. We're gonna roll those 10 dice, and you're gonna get, here's your 10 people. We want to look at obviously where we have women. So like for my set, I have 3 and 4 and 4 again. So 3 out of my 10. Interesting. That's about a third. 3 out of my 10 were women that were fired here. So what I would do is I'm going to share my result. So I'm going to go to slide 3 here on the Jamboard. I'll drop the link for the Jamboard again so you guys can get into it. I would drag a dot to about a third, 0.33. And that's going to be my result. And so you're going to go ahead and roll your dice and then put down your p hat, so the proportion out of your 10 that were women, and then drag your dot over. We're going to try to do it twice because we're a small class. So if you could do 2 sets of 10 dice rolls, and then drag your dot over. So let me drop. Oh no, the share settings. Hold on. I bet you're all, yep, your viewers. Hold on, edit, done. Okay, refresh the page or I'll drop the link again. Should be editors now. Drop it again for you guys at home. Re-click, sorry about that. Okay, so do your 10 dice rolls twice. So do 2 sets and then drag over 2 dots based on the proportion that were females, and then we'll investigate. I would play a little music, but I'm too afraid to click extra buttons at this point. So best of luck, friends. Drop in the chat if you've got a question, and I'll see your dots dragging over, hopefully. Anyone having trouble moving the dots? I don't know. Nothing's moving for me, so I'm just kind of sitting here wondering. Oh, look at that. Refresh the page. Everybody has moved dots. Okay. Great. Okay. All right. Looks. Oh, we've moved all the dots. Wonderful. I was like, why is nothing happening? Okay. Refresh. Everything's happening. Okay. All right, so we've got our dots here. So again, our claimed amount of people at the company is that we have about a third that are women. So we have all of our simulated layoffs here and the proportion in those 10 that were women. So let's take a peek and see what we notice now that we have all the things. All right, Cheyenne, do you mind unmuting? What do you notice about the dot plot we've got? Our little sampling distribution with all our little p hats.
That there's a peak around 30.
They're crazy. There's a peak around about a third. Yeah. Out of 10, we should get a big peak that represents the true people at the company, right? So we've got a big peak there. Cool. Anything else that we notice that stands out in our dot plot? Chris, what do you notice? Do you mind unmuting?
The shape is about normal. About normal.
Ooh, yeah, that is a great noticing. Look at this little bell-shaped curve. It's almost like we're gonna have to check the normal condition again at some point, or that large counts condition. Yeah, we got a great little. This is probably the most beautiful distribution I've ever seen with random data from the stats. Let's take another peek. Kai, what do you notice about the dot plot? Anything else?
There's no data in the 70% and up.
Yeah, no data here. Yep. So it stopped. We got nothing. We couldn't replicate any kind of results for having more than 70% or greater of the women being fired out of the 10. There's still something else I'm zeroing in on that we could maybe notice. Let's see, Ben. What else do you notice? Do you mind unmuting yourself, Ben? Is he still here? Yeah.
To me, it kind of looks skewed.
Okay, that's a good notice thing. You're zeroing. Which part of the graph the dot plot are you zeroing in on?
More how it just drops from 4 of them at 40 to 1 at 50.
Interesting. Okay. Saul, what was our p hat again? What did you say our data was? What was our proportion of women in the 10 originally that got fired? Do you mind unmuting?
It was 0.5, right?
It sure was. So let's take a peek then. Here's our 0.5. This was the result we were questioning, right? So let's count up our dots. How many dots do we have? 1, 2, 3, 4, 5, 9, 10, 11, 12, 13, 14, 15. We have 20 dots. Oh, perfect. We've got 20 dots. Okay. Out of 20 dots, here's our questionable result. And we said, all right, what's the chance that greater than a third of the women would get fired? And specifically, we're questioning the 50%. So 2 out of our 20 dots, we did this 20 times. That's what I'm counting anyway. 2 out of our 20 dots were women. It had more than 50% be women that got fired. So what is 2 divided by 20? As a decimal, we'll do a little mental math here. Tessa, what's 2 divided by 20? You mind unmuting yourself?
0.10.
Yeah, so we have a 10% chance right now, is what this is telling me. I have a 10% chance of acquiring a result that is 50%, having half of the women or more than half of the women in the 10 be fired, be laid off. There's only a 10% chance that my result happens. I replicated it 1 time. So let's talk about that. This is where we get a little bit, people get a little spicy. So let's take a peek. So should this person be suing, like right now? Should they be suing for gender discrimination? We only replicated this result 1 time, and even 1 more than that. That was a little greater. What are our thoughts? Lillian, what do you think? What are our thoughts? How do you feel about this person suing over the 50%?
I think they could because it wasn't very likely to happen that way.
Okay, yeah, the 10%. I mean, we only had one dot. Sure, it's a great thought. Let's call on someone else. Chris, what are your thoughts? And Aiden, why don't you drop some thoughts in the chat, and then we'll take a peek at those. Chris, do you mind unmuting? Do you think this person should sue?
Yeah, I'd also say yes, just because of how little of a chance that had of happening.
Okay, so low probability. We'll wait for Aiden to type something if he's there. Let's bounce around a little bit. Jake, what do you think? Do you mind unmuting yourself? Do you think this person should sue? What are your thoughts? No. Why do you think no? Feel free to enlighten us. It's interesting that you say no. So this is where it gets a little spicy. You think it's as fair as it could be. You still think it's a fair. So are you questioning? This is where we really get into it. Are you questioning? So a lot of people say like, well, the 10%. That's pretty low chance. But Jake, do you think the 10% is still fair? Like it's still a high enough chance that we shouldn't sue? Okay, interesting. All right. Let's call on one more person. Saul, what are your thoughts? Do you think this person should sue? So we've got a couple yeses. We've got one no so far.
I'd say yeah, just because I don't know how to explain it. It's just like that 0.5 is by itself. It's not necessarily fair, I guess, in my opinion.
Okay, so yeah, I mean, it's a high percentage of women. There's only a third at the company that are women, which we do have a big peak around a third. But yeah, this only happened one time purely by random chance, right? Us just rolling dice, and even one time more than that. So a lot of people question this percentage, and in statistics, we do need a cutoff point, some sort of general consensus about, okay, when is something considered a rare occurrence, when we can't replicate it a lot. How do we know if it's a rare occurrence or not? So here's where we're going to go. So if you're looking at the meat screen, we're going to kind of interpret some things here. So for us in stats, first of all, what we have to do is interpret what we got. So for us, we originally set up our claims to investigate a greater than situation. So our P hat was 0.5 originally that we were questioning for the women. And we're looking at, well, what's the chance that I get 0.5 or greater? What's the chance in general that I exceed that? So for us, based on random chance, it was only a 10% chance that we would get 0.5 or greater. So first thing is we have to interpret the 10%. As a statistician, we have to look at where our result fell that we were questioning. And then we have to tell people what that means. So this is kind of the sentence structure that you're going to want to get used to. So when we're looking at this probability, or what we're going to call a p-value, because it's a probability and that starts with p. So we would say, assuming the lottery is fair. So assuming we have a random, oh my goodness, we have a random. There we go. Assuming the lottery is fair, we did have to have that. There is, and we're going to insert our probability, a 0.1 probability, or we could say a 10% chance that we would obtain. And then what we're questioning is our sample proportion of 0.5. So that we would obtain a sample proportion of 0.5 or 50%. And in our case, we looked at greater than. And in our case, again, we looked purely by chance because I just rolled dice. I didn't actually go to this company and sample 10 random people and, fire them all and see how many were men and women. So assuming the lottery is fair, there's a 10% chance that we would obtain a sample proportion of 0.5 or 50%, or greater, he's writing this, or greater purely by chance. So the purely by chance part, if you want to highlight anything today, the purely by chance part is what's important, because the statistician has to sample things randomly, and they have to try to replicate the results through simulation a lot of times. And so we want to see if the company's claim is correct of that 30% are women, what is our chance purely by random chance that we would be able to replicate our result. So now we have to get into the dicey part of it, which is, have we convinced ourselves that this is gender discrimination? So Jake was the only person right now that said no to that. And I'm gonna rock everybody else's world, and I'm gonna agree with Jake and also say no, that this is not gender discrimination. But before people get, this is, if we were all in person, people would be gasping, and we would have this huge debate. But in stats, there is a cutoff point for when we are considered convinced that some result is unusual. Our Stickney results on Wednesday were in fact very unusual, and I would agree with our conclusion there. But here, we have not convinced ourselves in a stats world. We are not convinced because, and this is where we have to set that cutoff point in stats. And to a statistician, anything under 5% is considered weird. So since this is 10%, it's still a low percentage, but it's not low enough in the stats world for me to consider that this is gender discrimination. So I would say I'm not convinced, because 10% is greater than the 5% cutoff, is what I'm going to call it, the 5% cutoff. So the 5% cutoff is what is established in the stats world as something that this is not coming from anywhere in our situation right now. This is just, to a stats person, 5% under that likelihood, that is considered weird. So my 10%, even though it is low and something is dicey going on maybe at the company, it's not low enough. So this is usually where I get a lot of people asking questions. I know virtually that might be a little different, but this is our process here so far. So what questions do you have? And then I'm going to label some things. So what questions do you have about us not being convinced? So this woman shouldn't actually sue the company. So go ahead and drop some questions in the chat if you have them, or just feel free to raise your hand, hit the raise hand button, and you can unmute. Sometimes it's easier to talk this out. What questions do we have? And I will wait the appropriate awkward amount of time. Okay, I'm gonna try to launch a poll. Okay, I'm gonna type some answers. So just because this is very crucial at this point, if we understand or if we don't understand the decision we just made, I'm gonna launch a little poll to see who is, yeah. So hold on, let me type. So in the poll I'm about to launch, you're just gonna kind of rank your level of understanding of what just happened. Okay, save, launch. And I'm not going to publish these results. Like, I'm the only person that's going to see it. So that way I can just kind of tell where we all are. Because usually in the real world, in the real world classroom, I can see your confused faces, but I can't right now. So this is pretty important if we understand this or not. So I should have just launched a poll. Go ahead and tell me, if you get it, you sort of get it, like, yeah, I might get it. Or if you're like, whoa, what the heck just happened? There's an option for that. So go ahead and take a couple 30 seconds here, pick your level of understanding of what we just did. I got a couple votes. It's really important that I know who gets it and who doesn't, because this is not going away, this logic. This is the holy grail of stats right here that we've done today. So we got 5 votes. Good. 6 votes. 7. Okay, good. Keep them coming, people. It's like teetering back and forth on being tied and not tied. So it's very exciting. It's the exciting part of my morning. Right. Okay. Great. Okay, so keep the votes coming. I see 9 people have voted. I think we have 1 or 2 more than that, but feel free to let me know so I at least know where you are with your understanding. Okay, so let's go ahead and label some things. On your paper, question 6 is the holy grail of stats. This is the most important value in all of statistics, is this number right here, this 10%. This is called the p-value. So whenever we do any sort of statistical simulation, the p-value is the number I'm looking for to make my conclusion. So in this case, I have made a conclusion based on that, and I'm saying we shouldn't be convinced. So this number here is your p-value that is always based on your simulation. And it's crazy that Chris said it looks kind of like our dot plot was normal, because I'm probably going to use that at some point, get a z-score and a probability. You've actually been calculating p-value since chapter 2, but I just didn't tell you that. I am now. So this is the p-value, the 10%. So this 5% cutoff, like what the heck is that? People get a little spicy about this scenario because of, 10% is not great, but this 5% cutoff is what we call the alpha value, or the level of significance. And the level of significance, make this a little smaller. Thank you all for bearing with me today. Left the iPad at school. Okay, so the level of significance is where you're deciding to cut yourself off, like what is considered unusual or not. And 5% is always the default to a statistician. Every once in a while, we do increase it to 10% or we decrease it to 1%. So certain studies will increase or decrease their level of significance based on, where they want to cut their results off. So those are the 2 very important numbers that we're looking at when we do anything in stats. The p-value, what was our result? What was the chance of that happening? And was it less than or greater than our alpha value or our level of significance? So that's going to be basically it for today. So what I'm going to do is put up the important ideas slide. You absolutely have to write down these important ideas because they will never go away. This is literally going to be your life for the rest of the semester, is running significance tests for various situations and making statistical decisions about them. So all the steps we did here today are basically, you have done what every statistician does. We've simulated something, we've looked at the results, and we've made a decision. And we've got a little bit of a framework to do that in now. So these are our important ideas. And we're going to practice doing a full-length significance test in 4 steps. It's almost like we've done something in 4 steps before. In the last chapter, we've checked some conditions. We've had a formula. We made a conclusion, or we interpreted something. So in this case, we've done 3 things up to now, and this is how we want to formalize our understanding of those things. So we always have 2 hypotheses. We have a null hypothesis, which is the claimed amount. So for us, that was like the 33% from the company. And right now we're doing proportions. So we're doing proportions. We'll look at means or averages. We'll test out averages after, but we're going to stick with proportions for now. So P is the symbol we'll be using. And the null value, that is the claimed amount. And then we always set up an alternative hypothesis. And today we went in the greater than direction. We can also sometimes investigate the less than direction. And other times we just say, we just think the number's different. So there's a not equal to option. And then interpreting our p-value, this is very important. This is on the AP exam. This box, you need to make sure you interpret a p-value with this sentence structure, and we're going to practice this to our heart's content. But this is the approved way to interpret what we did. So assuming the null value is true, and I didn't do a formal interpretation just yet, but we're going to do it about 1,000 more times. So assuming our null value is true, so assuming we had a fair lottery, there is a blank probability of obtaining or getting our observed result or more extreme purely by chance. So the wording of or more extreme is kind of safe, and is, you know, it's meaning like it could be greater than, less than, not equal to. So just saying more extreme is kind of covers all those bases. And then purely by chance. So make sure you have this sentence structure written down. And then for our conclusion, this is where we're comparing it to our level of significance. And that gets this symbol in the stats world. It's the Greek letter alpha, which is our alpha value, our level of significance. So if we get a result for p-value, we're always going to compare our p-value to our alpha value and to make our final decision to convince ourselves. So if the p-value is less than alpha, I'm going to reject my original claim. If the p-value is greater than alpha, like it was for us, I'm going to fail to reject the original claim. So for us, our 10% was greater than 5%. So that means we can reject, we're going to fail to reject our original claim that there could be gender discrimination. So even though there's a third of people at the company that are women, it is possible 10% of the time to fire more women than a third out of the 10 by random chance. So we're going to practice this decision-making structure a lot more formally next week when we look at a few different other scenarios. We're going to kind of formally string together all of these pieces to write up a statistical test. It's going to be called significance test. So this is the other super important thing that has to be on your paper. You're going to need to remember when you reject an original claim and when you don't. And that's always, so that's going to be based on those things. So once you are done writing down these basics, you need to write them down, then you're free to exit today. So happy weekend, and thank you for playing along today. Have a great weekend.